So the concepts we're going to go over is the definition of standard form. So standard form is that ax plus by is equal to c. We're going to identify x and y intercepts on a graph. We're going to find them mathematically, and then we're going to use the intercept methods to graph. Okay. So that first concept, standard form, ax plus by equals c, says we can write linear equations in several forms. This form is the easiest to find both the x and y intercepts of a linear equation. So that's what's important here, is that we use standard form to find both the x and y intercepts. It will also be useful in the future when we start solving systems of equations. Just note that a, b, and c are all real numbers, and x and y are our variables. So in these examples, we are going to identify if the following equations represent a linear equation in standard form. Okay. So we're looking for that ax plus by equals c format. So looking at number 1, we have 3x minus 5y is equal to 10. Do we see our a, b, and c in that form? Yep, so that means this one is in standard form. So we are going to go ahead and I'm going to label this as a, b, and c because we can identify each part of that standard form. And then we're going to go ahead and take this, since this is a linear function, and we are going to get y by itself. So more practice of what we were doing in topic 5. So y by itself. Okay. So in order to get y by itself, what do we have to move over first?
The 3x.
Good, that 3x. So it's a positive 3x, so I'm going to subtract the 3x to the other side. When I do that, can I combine that 10 and that 3x? No, okay, they're not like terms. So we have negative 5y is equal to negative 3x plus 10. Make sure you always write your variable first. So in this case, the negative 3x went in front of the 10. Okay. What would be our last step to get y by itself? Good. Divide by negative 5, and that's going to be every term by negative 5. So then I'm left with y is equal to negative 3 over negative 5. I'm just going to cancel out those negatives and leave it as the fraction 3/5 x. And then 10 divided by negative 5, negative 2. Okay. So again, we see that this is indeed standard form because when we got y by itself, we ended up with an equation that looks like y equals mx plus b, which is in what form? Do you guys remember from last class? What is the name of this form? Slope-intercept form. Good, slope-intercept form. Okay. Looking at the problem where we got y by itself, is our slope positive or negative?
Positive.
Positive, because what number are we looking at?
3 over 5.
3 over 5, that's our slope. So if we were just to draw a rough graph, we know that it's going to be a line that is going in the positive direction. So the answer to this one is yes, that this is linear. Okay, looking at number 2. On number 2, we have 3x is equal to 15. Do you think this is in standard form, yes or no?
No.
Okay. What is it missing in order to be standard form? It's missing that y. So in this case, could y be 0? Yep, y could be 0. So if we were to rewrite this, this could be 3x plus 0y is equal to 15. Does this look like standard form? It is. So this is our A, our B, and our C. Okay. So even though our original problem that 3x equals 15 does not look like that it is in standard form, it is, just the y was 0. Okay, and that's the same for the opposite. If we had like 3y equals 15, we would still say this is in standard form, just that the x value is 0. Okay, so if I go ahead and solve this, that 3x equals 15, and divide both sides by 3, I get x is equal to 5. How would the graph of x equal 5 look like? So,
straight line?
good, it would be a straight line in what way? Horizontal or vertical?
Oh, vertical.
Vertical, right? Because our x's are here. So let's say this is 5. So our graph would look like a line going through 5. What would the slope of this graph be? What would the slope be? Say that again?
Infinite.
You're on the right track, not infinite.
Undefined.
Undefined. The slope here is undefined. Okay. The reason it's undefined is because if we were to try to find the slope here using that, that rise over run, we would end up with a fraction that has 0 on the bottom. And just remember that we cannot divide by 0, so that makes it undefined. So any of the graphs that are a vertical line are going to be undefined. And then, however, our question was asking if this linear equation is in standard form, so our ultimate answer is yes. Okay. What about number 3? Is this in standard form? Yes or no? No, it's not in standard form. How can you tell?
X and Y variables.
Okay, good. It's missing like an x and y variable. And where is that x variable? It's an exponent. So if we see our variable in the exponents, what type of function is this? It's not linear. Any guesses? Just remember that like mathematicians are not very creative with their names.
Would it be quadratic?
So it's an exponential function. Okay, so that means this is not in that ax plus by equals c form, which makes sense because this is not a linear function, this is an exponential. So we would say our answer is no. And then just so you have it on the notes, an exponential function kind of looks like a curve like this. Okay. What about number 4? Is this in standard form? Yes or no?
Yes.
Are you sure?
Not no more.
I guess no, because of the exponent.
Correct. So even though it looks like it is in standard form, we automatically can tell this is not linear because of that x squared. What type of function is this?
Exponential.
So it's only exponential if we have a variable in the exponent. So if we have our exponent squared instead of linear, it's the next one up, which is quadratic. So if we see this x squared, this means it's a quadratic equation. So not linear. Meaning our overall answer is no, this is not in standard form because it's not linear. And then remember, exponential functions look like that U shape, but since our number in front of that x squared is negative, that U is going to be upside down. Okay. And we're going to talk more about this when we get to the topics of quadratic equations. Okay, any questions so far? Okay. Okay, looking at number 5. Is this in standard form, yes or no? It is in standard form because our x is 0. Remember, this looks like number 2. On number 2, we had just an x. Now we have just a y. So there are ax plus by equals 0. This 4 is what letter? Oops. It's B. Sorry, I made a mistake here. Not 0. It should be C. And then the 16 is C. So that means we're missing A, so we assume that A is 0. Oops. There we go. Okay. So that means we could technically rewrite this as 0x plus 4y is equal to 16. So here we have our A, B, and C. Okay. If we solve this, 4y is equal to 16. Divide both sides by 4, we get y is equal to 4. What would the graph look like this time, now that we're dealing with y instead of x? A horizontal line, good. So let's say we have 4 here. It would be a horizontal line. Okay. So we know that the vertical lines are undefined slope. What is a horizontal line? What's the slope?
0.
It's 0 because this is a flat surface, which means it does not have a slope. So our slope would be 0. Okay. And then number 6, is this in standard form, yes or no?
Yes. Flipped.
Yes, it is in standard form, and yes, it's just flipped. So we have our equal sign on the wrong side. So if I was to rewrite this, I would have 3x plus 6y is equal to 18. I would just move that equals to 18 on the correct side. So I could label this as A, B, and C. Okay. So what we're going to do here, since we did prove that this is in standard form, we're going to get y by itself. Okay. So in order to get y by itself, what are we going to move first?
3x.
Good, that 3x. So I have 6y is equal to, how is this side going to look?
Minus 3x plus 18.
Good, negative 3x plus 18. X always comes first. Okay, last step here is going to be what? Good, so what are we going to do to remove that 6? Divide everything, every term by 6. Okay, so we have y is equal to negative 3 divided by 6. Can that reduce
Yes.
to what?
1/2.
Negative 1 over 2. Yep, negative 1 over 2x. And then what about 18 divided by 6? Can that reduce to 3? Okay, so this would be our equation in what form?
Standard.
Slope intercept. So remember, we started with standard. This is the standard up here. And we went into slope intercept form. And we know this is slope intercept form because we have our slope and our y-intercept. Just keep that in mind. They weren't very creative when thinking of these names. So, okay. So the overall thing you need to know from this section is that standard form can't have a variable as an exponent, because then it is now an exponential function. And it can't have any numerical exponents, because then that would make it a different type of function, like quadratic, cubic, and so forth. So no numerical exponent and no variable exponent. Okay. Well, and remember, this is all being recorded, so you'll be able to go back and look at that. Any questions on this concept? Okay, we were just determining if it was in standard form. Next concept, we're identifying the x and y intercepts on a graph. So it says when looking at a graph, we can find the x and y intercepts by looking at where the function crosses the x and y axis. So in these examples, we are going to identify them and write them as points. Okay, so looking at number 7, what is the x-intercept?
4.5.
Good, about 4.5. So right here, we're looking at the x-intercept because it crosses the x-axis right here. Okay. And then we would write that as what point?
4.5, 0.
Good, 4.5, 0. Okay. Remember, with these points, if we have a point in between two numbers, you are giving your best estimate, okay? So this one looked like it was in the center, so that's why we said 4.5. What if it was closer to the 5? What would be a good estimate for that point? If it was closer to the 5?
4.75.
Yep, 4.75, 4.8, 4.9, any of those answers would be acceptable, okay? So now looking at the y-axis, what is our y-intercept? 3 right here, because that's where it crosses. Okay, so how would we write that point? Good. So the y-intercept, 0, 3. When you are being asked, what is the x-intercept? What is the y-intercept? Your answer is always going to be in the form of a point. Okay? Always the form of the point. Never write y equals 3 or x equals, in this case, 4.5. Don't write those equals, because remember when we did the last concept, when we had y equals something or x equals something, that gave us a graph of either a vertical line or a horizontal line. Okay, and it's not asking for that, it's asking for a point. Just make sure you write the points. Okay. So on number 8, what would be our x-intercept? Good, -4, because that's where it crosses that x-axis. And how would we write that as a point? Good, -4, 0, because this is the x-intercept. Okay, what about the y-intercept? Good, 0, 2, because it crosses right there at 2. So this is the y-intercept at 0, 2. Notice that in our intercepts, we always have a 0 in one of the values. Okay, we'll always have a 0 in one of the values. X-intercept will have that 0 in the y's. Y-intercept will have that 0 in the x's. Okay. Okay, for number 9, what is our x-intercept?
-5, 0. No, 2, 0.
2, 0, right here. We're looking at the x's. So it crosses right here at 2, which we know is 2, 0. So this is our x-intercept. What about our y-intercept? Good, it crosses at -5, but what would our point be? 0, -5, okay? if on an exam you switch these up and you write -5, 0 or 0, 2, they will be marked wrong. Okay, so make sure that we know where the 0 goes when we're writing a x-intercept versus a y-intercept. Okay. Okay, number 10 doesn't have any numbers on our graph, so we're just going to assume that it goes up by 1. Okay, so looking at our x-axis, what is our approximate x-intercept? Good, 3.75 would be a good answer. Another good answer could be 3.8, 3.9, 3.95. You write any of those on an exam, that would be correct. So we'll just say 3.75. This is our x-intercept. How would we write that as a point? Good, 3.75, 0. Okay, now y-intercept. Good, 0, 3. So we're assuming this is going up by 1s. If you don't see any numbers on your graph, you always assume that your units are going up by 1, okay? So this is our y-intercept. We say that it crosses at 3, which is the point 0, 3. Okay, and this is us again identifying these intercepts when given a graph. Okay, number 11, what would the x-intercept be? Good, -4, 0. So right there on the x-axis, it crosses at -4. This is our x-intercept at -4, 0. Okay. What about our y-intercept? 0, 2. So right here it crosses at 2. So it would be 0, 2 as our y-intercept. Okay. What do we know? What do we notice that's different about number 12? Good, there's no x-intercept. Why is there not an x-intercept? How do we know that just by looking at the graph?
Because there's no slope. It doesn't cross the x-axis.
Good, it doesn't cross the x-axis. There's no slope. All of those things are valid. So right here is our x-axis. Our function never crosses it, so there is no x-intercept. What about y-intercept? What would that be?
5.
Good, 5. Because right here it crosses at 5, which we would write 0, 5 as our y-intercept. Okay? And then we said that this had what type of slope?
It doesn't.
It doesn't have a slope, so no slope. Remember, if it has no slope, that's a horizontal line.
Constant.
If it's a vertical line, then that's undefined. Undefined is a vertical line. So since this has no slope, we know the y-intercept. Who could tell me what the equation to this is? Y equals 5. Okay. Good. Any questions on this concept? Finding x and y from a graph. Now we're going to be finding x and y mathematically. So we're going to be given an equation and we're going to have to find both the intercepts. So when trying to find them mathematically, we just have to remember the concept that the x-intercept is x, 0. So whatever that number is for x, and then y is 0. And then that y-intercept, x is 0. So y is 0. Just think the opposite. So y is equal to 0. X is equal to 0. So on the examples, it says find x and y intercept of each equation. So we know now that these equations are all linear because it's asking us to find these x and y intercepts. So we don't need to determine if it's in standard form or what form. We're just going to be using these equations and either plugging in y, 0 for y or 0 for x. Okay. So I'm just going to split it in half. So first, finding our x-intercept, we know that we have to plug in 0 for what variable? Good, y. So I'm going to go ahead and rewrite my problem, but plug in 0 for y. So 4x plus 5 times 0 is equal to 20. Okay. When I plug in that 0, that goes away, and we just have 4x is equal to 20. Okay. When I get x by itself, I'm left with what number? X equals 5. Okay. This x equals 5 is giving us one part of our answer. It's just telling us that when y is 0, x is 5. How do we write our x-intercept as a point? 5, 0. So this is the answer right here. Okay. That 5, 0. So remember, when we're finding the intercepts, our answer is always a point. Okay. So now we found the x-intercept. We're going to find the y-intercept. And the y-intercept is plugging in 0 for what variable? X. Always the opposite. So we have 4 times 0 plus 5y is equal to 20. That 4 times 0 cancels, and we're left with 5y is equal to 20. Divide both sides by 5, and I get y equals 4. How would I write that as a point? 0, 4. Okay, so that's finding the x and y intercept. Now looking at 14. X-intercept is when what variable is 0? Y is 0. Plugging that in, I get 2x minus 0 is equal to negative 4. That minus 0, that cancels out. So we have 2x equals negative 4, which means our x is equal to what? Negative 2. So that means our answer is negative 2, 0. Okay. Y-intercept is when what variable is 0? So now we're plugging in 0 in for x. So I have 2 times 0 minus y is equal to negative 4. That 2 times 0 cancels. And when I bring down my problem, am I going to bring down just the y or the negative y?
Negative 1.
Good. I'm bringing down that negative y because it's attached to the y. So I have negative y is equal to negative 4. How am I getting y by itself?
Divide by negative 1.
Good. Divide by negative 1. That's what's going to cancel out the negatives there. So that means I'm left with y is equal to 4, which means our answer is 0, 4. Remember, if you switch up the values when you're writing these x and y intercepts and put the 0 in the wrong spot, it's going to be marked wrong. So just make sure our 0 is in the correct spot. Okay. Okay, go ahead and work on 15. Give you guys a few seconds to work on that, and then we'll go through it. So once you have both the x and y intercept, go ahead and just look up from your paper so I can see who is still working. Okay, so let's go ahead and start working through it. So our x-intercept is when y is equal to 0. So I'm going to plug in 0 for y. So I have x plus 2 times 0 equals negative 2. That 2 times 0 goes away, and I'm left with x is equal to negative 2. I don't got to solve any further because my x was already by itself. So writing this as a point, I get negative 2 comma 0. For the y-intercept, you should have got that. The y-intercept is when we plug in 0 for x. So I get 0 plus 2y is equal to negative 2. That 0 cancels out. So I'm left with 2y is equal to negative 2. Divide both sides by 2. Y is equal to negative 1, which I can write as the point
0, negative 1.
0, negative 1. Okay, so those are the points you should have got for 15. Okay. Now looking at 16, we're going to do the same. So x-intercept, I'm going to go ahead and plug in my 0 for y. When I plug in 0 for y, that 5 times 0 goes away. Also, that negative attached to it goes away. So I'm left with 3x is equal to 15. Divide both sides by 3. X is equal to 5, which gives me the point 5 comma 0. Y-intercept, I'm going to plug in 0 for x. So I get 3 times 0 minus 5y is equal to 15. 3 times 0 cancels out. I'm left with negative 5y is equal to 15. When I divide both sides by negative 5, I get y is equal to negative 3, which gives me the point 0 comma negative 3.
So, question. I know that we're doing the extra step of, canceling it out with the 0, but
Yeah.
in theory, can we just ignore it?
Yes, you could. So, let's do that in 17. Yeah, remember I'm doing step by step by step, since these are your notes. But yeah, we could just ignore it. So let's say we want to find the x-intercept. So we know that the y's are going to go away. Okay, so let's say x-intercept. Okay, so the y's are going to go away. So I could just cross this part out and then look at the problem like this. 3x equals 6. 3x equals 6. Leaves me with x is equal to 2 once I divide by that 3. And so I get the point 2 comma 0. So as you keep doing these, you'll get to the point where you don't have to write all those little steps. Okay, you could end up doing a lot of this in your head. And then, okay, now we're finding the y-intercept. So now I'm going to cross out the x's. Okay. So for the y-intercept, I'm left with negative 2y is equal to 6, which leaves me y equal to what number? Negative 3. So I have 0, comma, negative 3. So yes, you could just ignore the opposite variable and whatever's attached to it to find these x and y intercepts. Okay. If you are not, let's say, if you're not comfortable doing it this way, show all the steps, just so you make sure you are getting the correct answer. On the test, I need to see some work. So if you show me at least this work that I wrote here on 17, that's enough work, okay? Because here I can see that you are getting rid of the opposite variable by plugging in that 0, okay? This work is ideal, okay? Because anyone who would look at the test, even if they did not know how to solve x and y intercept, they could follow your steps, okay? But I will accept this. This would be the bare minimum work I would need to see. Okay. So definitely for these ones, don't just write your answers out, even if you can do them in your head. Okay, so this is another one where it would be just easy to ignore the opposite variable because we don't have any coefficients in front of x and y. So if we were finding the x-intercept, I know that this y is going to be ignored. And so I'm left with what? X equals 5, which is what point? 5, 0. Okay. And then for the y-intercept, I know I'm ignoring what variable? X. And so I'm left with what? Y equals 5, which is what point? 0, comma 5. So again, yes, this would be another one where you could just ignore that opposite variable. It would be really easy to do without doing all those extra steps. Any questions on this concept of finding the x and y intercept? Okay. Now we're going to use this method that we just learned, and we're going to use it to be able to graph our functions. Okay. So when we are graphing linear functions, we only need 2 points. As long as we have 2 points, we can create a line. So the 2 points we're going to use, since we just found out how to find them, are the x and y intercepts. So we're going to first find the x and y intercepts for the problem. Then we're going to take those answers, since they are written as points, and we are going to plot them and then create our line. So first I'm going to do the x-intercept. So I'm going to be plugging in 0 for y. So 5x plus 2 times 0 is equal to 10. The 2 times 0 cancels, so I'm left with 5x is equal to 10. Dividing both sides by 5, I get x is equal to 2. And how do I write that as a point? 2, 0. Okay. I'm going to go ahead and plot that point, 2, 0, which is right here. Okay. Now I'm going to find my y-intercept. So I'm plugging in 0 for x this time. So 5 times 0 plus 2y equals 10. 5 times 0 cancels out. I'm left with 2y is equal to 10. Dividing both sides by 2, I get y is equal to 5, which leaves me with the point 0, comma 5. So I'm going to go ahead and graph that point too. Now that I have my 2 points, I can connect them to create my graph. Would I connect them like this?
All the way through?
All the way through. We would connect them all the way through. Okay? Because we are finding the graph of the entire function. There's no restrictions on this. There's no restriction on domain. There's no restriction on range. So we have to assume that these both go on forever.
May I ask a question?
Mm-hmm.
So this is where last year I had struggle with.
Okay.
In this situation, if it was asking for the slope, then we would turn that equation into y equals mx plus b?
Correct. Correct.
Yeah, you've simplified it so much for me.
Well, thank you. Or another way another way we will look at it is doing the rise over run to find the slope. So if we have the graph, we could just do, for example, rise over run. So 1, 2, 3, 4, 5 up and 2 in the negative direction. So our slope would be 5 over negative 2.
No way. That easy?
Yeah. Yeah.
That's cool.
So we'll learn about that, I think, in a couple more notes. That how to find the slope with a graph, and then, like you said before, we would turn it into y equals mx plus b to find the slope if we weren't given a graph. Okay, so looking at number 20, we could do this 2 ways. We could go ahead and start solving with the fractions there, or we could get rid of the fractions. What would you guys like to do? Keep the fractions or get rid of them? I prefer to get rid of them, okay? So in order to get rid of them, we're going to have to multiply the entire equation by a common denominator. So what would be the common denominator between 4, 8, and 2? 8. So I'm going to multiply every term by 8. Okay. When I'm multiplying every term by 8, I can assume that 8 is a fraction that looks like 8 over 1. Okay. So that means I technically have fractions being multiplied by fractions. When we have 2 fractions that are being multiplied together, what do we do to the numerators and the denominators? Multiply across. So I'm writing this out step by step. So I have 1/4 times 8 over 1, negative 1/8 times 8 over 1, and 1/2 times 8 over 1. Okay? So if I was to multiply each of these across, what would I get in the first fraction? 8 over 4, which simplifies to 2. What about the second one? 8 over 8 or negative 8 over 8? Negative 8 over 8, which reduces to negative 1. And then the last one? 8 over 2, which simplifies to 4. Okay, so that means instead of 1/4 y minus 1/8 x equals 1/2, we have the equation 2y minus x, because we don't need to write 1x, is equal to 4. Okay. So we did that one extra step, but now we have a prettier function to find our x and y intercept. There's no more fractions. Any questions on how I did that? Okay, so now finding my x-intercept, I'm going to plug in 0 for y. So it does not matter right now that my x's and my y's are mixed up, because I'm going to end up plugging in a 0 for one of them anyway. Okay, so I have 2 times 0 minus x is equal to 4. 2 times 0 cancels, and I'm left with negative x equals 4, which means x is equal to what? Negative 4, if I move that negative over. What would be my point since this is an x-intercept?
Negative 4, 0.
Negative 4, 0. And I'm going to go ahead and plot that negative 4, 0. Okay, it's right here. Then I'm going to find my y-intercept, and I'm using this equation here. So I'm going to be plugging in 0 in for x. So 2y minus 0 is equal to 4. That minus 0 cancels, and I'm left with 2y is equal to 4, which means I have y equal to what number? 2, which means my point is 0, 2. Plotting that point. Now I have my line here. Okay, let's go ahead and look at 21.